All right, guys, we are into the funness of it all, the unit circle. And like I said yesterday, you still need to memorize it. All right, so we're going to review things that you should already know. Hey, have your gossip later. We're going to review what you should already know, such as 30, 60, 90 triangles and 45, 45, 90 triangles, which I hope you recall. Yes? All right, so 30, 60, 90, and 45, 45, 90s are called our special rights. The reason why they're called special rights is because there's a relationship between the angles and sides. We call that a ratio, right? There's a ratio between all three sides. And because there's a ratio, that means that if I know one side, then I know all of the other sides. Does that make sense? All right. So up first, we're going to establish what the ratio is. So you have a 30 degree. Across from 30 degree, that's what we call our x side. You have your 60 degree angle across from 60. It's the ratio for that is x square root of 3. And across from your 90 degree, it's going to be your 2x. Okay, so that means if I know what x is, or if I know one of these pieces, then I automatically know the rest. Okay, that's what makes it special, is because unlike most triangles, we have to know two pieces of information. For 30, 60, 90s, and 45, 45, 90s, you only have to know one piece. X is the side that you're going to establish. So we're going to figure out what X is in particular to this triangle. Does that make sense? All right, so this triangle, we know that it has a hypotenuse of 1, right? It says the hypotenuse is 1. The hypotenuse is across from what angle? 90. So we know that across from 90, that ratio is 2x. And it says that our hypotenuse is 1. So we know that 2x equals 1. Across from the 90, the ratio is 2x. And we know that that equals 1. Can we establish what x is for this problem? Yes. What is x? 0.5, 1/2. So we know that x equals 1/2. So now I know the rest of the sides, right? So across from 30, it's going to be 1/2. Across from 60, it's going to be square root of 3 over 2. That's not a 3. I can write. I promise. Okay, that's because 1/2 times square root of 3 is square root of 3 over 2. Yes?
I did it. I didn't know.
Oh,
I guess.
from geometry? That was a geometry question.
Yeah.
It's all right. It's all right. That's why we're reviewing. Remember, I said I'm not going to assume that y'all recall geometry. So here we are. For your 45, 45, 90, the ratio is across from your 45 degree angle. You call that x. You have two 45 degree angles, so that means you're going to have two sides that are the same length. And across from your 90 is your x square root of 2. So here, the hypotenuse again is 1. Can you tell me why we're using the hypotenuse as 1? You want to take a guess? A unit circle, because this triangle is going to be drawn into a unit circle, and a unit circle has a radius of 1, and so it's called a unit. Okay, so now across from 90, we know it equals what? 1. So what would I need to do to get x by itself here? I just divide. Same thing. Just like you divided by 2 here, this time instead of 2, you're dividing by square root of 2. Okay? Yes? Yeah. You don't just start making stuff up. All right. Now, this is where we talk about improper form of mathematics. It is improper for your radical to be in the denominator. We don't make it a negative. It's called ratifying. And to ratify, we're going to multiply the numerator and the denominator by that radical. The reason why you do that is because a radical times itself sets itself free. So now we have square root of 2 over 2. Okay, so now we know the value of all of our x's. So across from our 45s, the values is going to be square root of 2 over 2. This little triangle is super duper duper important because when we talked about the triangle and how your x's and y's, once it's in a unit circle, those become your sine and your cosine, right? Well, these are, when I draw this in a unit circle, this is going to become my x and my y. So let's talk about what that looks like in circle form. So up first, we have here our cosine, our x value. So this is our x. Our x is square root of 3/2, and our y is 1/2. So I'm going over square root of 3/2, and I'm going up 1/2. That's what that's telling me. Agree? So it said that when we talked about in part A, we established that when you're drawn into a unit circle, your order pairs also represent your trig values. Do you remember that from 2 days ago? Yeah. What does x represent? Part your cosine. Your x is your cosine. So it's asking me to find the value of your sine, your cosine, and your tangent. So remembering the rules, if I'm looking for sine of an angle, it's going to equal the y value. If I'm looking for cosine of an angle, it's going to equal the x value. And if I'm looking for the tangent of an angle, it's going to equal y over x. That's what we did in part A. Ringing some bells a little bit. Okay. So therefore, what is the sine of this angle? 1/2. What is the cosine of this angle? I was gonna wait. I was patiently wait. I was gonna wait. And then the tangent here is what? A little different. It's gonna be a little bit of multiplication happening here. We have a fraction, 1/2 over square root of 3/2. How do you simplify fractions? Multiply what? Nope.
You multiply it by the denominator. No,
Reciprocal. You multiply by the reciprocal. Did you say it? I didn't hear you. If I didn't hear you, I didn't say no. I didn't hear you, bro. All right. Also, remember, keep, change, flip is a little way to remember how to multiply fractions. You're going to keep the numerator. You're going to change from division to multiplication, and you're going to flip the denominator. That's what it means to multiply by the reciprocal. Because the reciprocal means that you are flipping that fraction, right? What happens to my 2's? They cancel, and we're left with 1 over the square root of 3. Up. I didn't hear you say that. Yeah, I didn't hear square root of 3 at all. Nope. I probably do. I didn't hear it. Did you all hear her say it?
Yes. They both they're both divided by 2, so doesn't that just cancel it out? Is that what my thought process?
Oh, I didn't hear that part. I mean, yes, because it's both in the denominator. I was just telling you the mathematical reason. What if they wanted to? Would you still know what to do?
What if they're the same number?
Yeah, they're both the same in the denominator. But I'm saying, what if it had been 1/2 over square root of 3/4? Would you remember how to divide the fraction? So whether or not, we still need to go through the process. All right, what did we just say you're not allowed to have in the denominator? A radical, right? And how do I get rid of it? Multiply. So therefore, our final tangent equals square root of 3/3. So here's our tangent, here's our cosine, and here is our sine. Guess what you're gonna do? It's your turn. You're gonna do it on example number 7. Okay. I gave y'all the easy one. Y'all always complain that I give you the hard one. Now you're complaining because I gave you the easy one? Really? This makes no sense. So don't even try to complain. As you're finishing up, check with the nearby person. I just said, don't overthink it, guys. Don't overthink it.
Wait, what do we change? I thought for a second I was trying to change that. Girl,
I
you
already
know,
I already overthink it.
I just said, don't overthink it. Don't overthink it.
Miss, I got here and then I'm stuck.
You overthought it.
Yeah.
What's anything divided by itself?
Oh. Oh. Oh.
Why? I'm telling y'all not to overthink it. All right, let's go. Okay, remember your X, your Y. So sine theta is what? Sine is from our Y, which equals square root of 2 over 2. Cosine theta is from our X, which equals also. And tan theta is Y over X. And anything divided by itself is 1. I love y'all so much, my overthinkers. There was no steps to follow. Use your logic. All right, here you go. Go again, real quick. Number 8. I wonder why it looks familiar. Why are you looking at me? You got this. No, we're all in this together.
Then we just be. Is that right?
All right, here we go. Remember, your X, your Y, and everyone has a job, right? Sine theta equals what again? And our Y value is? There we go. Cosine theta equals what? And our X value is? 1 over 2. Tan theta equals what? Y over X, which gives us. And if you keep flip really quick, what's going to cancel out? And what are you left with? Square root of 3. That means we got it. Yes, I knew y'all were geniuses all along. All right, let's talk about what theta is, okay? So looking at our thetas, we're going to establish the values of our thetas by knowing this information, okay? So if I am 30 degrees, my adjacent is square root of 3 over 2. My opposite is 1/2. Do we see that?
Oh.
Yeah. If I'm 60, my adjacent is 1/2. My opposite is square root of 3 over 2. So this is your X, your Y, your X, your Y. Do we see that? So that's how knowing this triangle can help you when you get to the full unit circle. Okay, so here, this theta value is what then? It's our 30. So for this triangle, for this triangle, this angle, theta equals 30 degrees.
Say that whole thing.
Okay, what is its adjacent value? Square root of 3 over 2. What is its opposite? Let's go back and look at our triangle. What is its adjacent value? What is its opposite? 1/2. Okay, so what is theta here? It's our 45. So theta is 45 degrees. So this is the sine, cosine, tangent of 45 degrees. Does that make sense?
So it can only be if you do like 1 or 2.
As of right now.
Oh, that one's 60.
And then this one is 60. Okay. No, now that you've established that this is 60, if I ask you for the side of 60, you should be able to say, oh, the square root of 2. Cosine of 60. Oh, that's 1/2. You don't have, the goal is to have it memorized where you don't need the circle or the triangle. However, they're your foundation. All right. They're always there. Okay. All right. Next, we're going to talk about what if I am not 30, 60, or 45? What's the angle I'm missing from the 90? What about 90? You know, what if theta equals 90? What does that look like? Okay. Well, when theta equals 90, that means that you've gone from 0 to here, right? You've gone. Okay. What did we say was the ordered pair when I'm at 90 here then on a unit circle? We said that was 0, 1, right? So at 90 degrees, your x is 0 and your y is 1. So can I establish the sine and cosine of 90? So what is the sine of 90 degrees? Well, sine is based off of your y. And what is the value of my y? 1. You're good. Cosine of 90 degrees. Cosine is based off of your x. And what is the value of my x? 0. And tangent is y over x. So that's 1 over 0. That is undefined. Okay, remember, it is okay for 0 to be in the numerator, but it is a no-go for 0 to be in the denominator. Okay, okay in the numerator, we equal 0. No-go in the denominator, it is undefined. Got it? So our 0 is in the denominator, which is what made it undefined. Okay, yes? Now we've established all 4 of those angles, right? We have our 90, our 60, our 45, and our 30. If you know those 4, you can figure out the rest of the circle. Okay? If you know those 4, the rest of the circle is going to be easy peasy, lemon squeezy. All right. Yes. So in summary, the sine of theta is equal to the what of the point? The y. Perfect. My y coordinate. The cosine of the theta is equal to your x coordinate. And your tangent is your y divided by your x. Y divided by x. Yes? All right. Now, looking at all things you wrote in, you're going to fill in this table. So fill in the table with the sine, cosine, and tangent of all of our special angles. Go for it. So using your triangles, the information already did, you're going to fill in the simplified. Yeah.
What?
It'd still be the same, but now you're in the 4th quadrant. There you go. Sorry.
But what about like, if it was over here?
And sine A, cosine A. There you go. Because in that quadrant,
Oh,
your
wait.
x and your y are.
Oh, it's fine.
Yeah.
Oh, I didn't.
Yeah.
Wait, or this is the tangent. Wait.
Yep.
Wait.
What?
Real.
All right. Fill it in our tables. Fill it in our tables.
Real.
I really want to know whose shoes those are.
What time do
For my head.
we
All right. Cosine. How do we do on 30? 45s. Good. Did you notice relation between anything? They all have division by 2. What about between 30 and 60? What did you notice?
Oh, wait, it's.
They're opposite. They're switch. Your sine and cosine switches, right? All right. Yes. Doable? All right. What time is it? Good. Oh, that's fine. We can do this. We're just divided by ones and zeros. Here we go. Sine. So we're gonna do 0. So we already did 90, right? We already found 90. What did we have for 90? So at 90, what was our sine? 1. What was our cosine? And what was our tan? Undefined. Okay, now we're gonna do the exact same thing we did with 90, but with 0. So at 0, what's my sine? 0. Cosine, what's my sine at 0? My cosine is 0. 1. What is my tan? 0. Okay, pi. What's the sine? Sine is what? Which one? Our 0, because it's our y. What's our cosine? What's our cosine? -1. And then what is our tangent? 0. 0's in the numerator. 3 pi over 2. -1. 0 and undefined. Yes, we got our quadrantals. We finished. We did it.